Alright, so today what I want to do is demonstrate a method of factoring that I modified from a method I discovered while working at Valencia College, Aspen award-winning Valencia College. And so I think this method is far superior to the AC method that is seen in many algebra textbooks. And this is basically because the numbers never get as large in the AC method when you're multiplying the A and C coefficients together. It also takes advantage of some of the mathematical realities of the factoring problems and the distributive property. All right, so I call this method the X factor method of factoring. Okay, so the X factor method of factoring. All right. And so the reason I like this method is because it's halfway between the intuition method of trial and answer, right, and completely structured AC method. So it's kind of halfway in between. Students really like this. So in this video, I'm going to introduce the method with a simple example, and then to my hope, I will do a follow-up video with some more difficult to factor trinomials. And of course, that makes us all very happy. All right. And so to start, what you want to do is you want to find the factor pairs of the first term and the last term, okay? And specifically, you want to make sure that you put these in order, starting with 1. So now, it's been a while since I used my pen to do something like this, but that's what I'm going to do now, all right? So as you can see, the first term is 6x squared. And so what I'm going to do is I'm going to draw two little arrows down to make the factor pairs, okay? And I'm going to go ahead and start with 1. And so 1x times 6x gives you 6x squared. And 2x times 3x gives you 6x squared, all right? And then I'm going to do the last term, okay, which is the 15. And so again, starting with the 1, I'm going to do 1 times 15, and I'm going to do 3 times 5. And so that is the first step. Okay, and so now I have my factor pairs here. So what I'm going to do is I'm going to scroll up so we can get a better look at, oh no, at what is going on. Alright. And so here's what I want to do. Sorry about the jumpiness here. And so here's what I want to do next. I want to draw an X. I want to draw an X, putting the first term pairs in the front of the X. So that's going to be this 2x and 3x. And the last term pairs in the back of the X that I draw. And that's going to be the 3 and the 5. Okay? And so you want to work from the bottom of the list to the top. I'm going to work 2x, 3x up, 3 and 5 up. Don't forget you can flip in the X. Actually, let me talk about these later, right? So let me go ahead and draw what this looks like, right? So what I'm going to do is I'm going to put a nice X here, and I'm going to draw a little arrow to remind me this is my direction of multiplication. I'm going to draw a nice X here to remind me that this is my direction of multiplication. And so what I'm going to do is I'm going to take the 2x and the 3x, and I'm going to put that first term pair in the front. So here's my 2x and my 3x that go in the front. And then I'm going to take my 3 and my 5, and those are the last term pairs, and they're going to go in the back. And so I would never want to put a GCF on the same row. So I don't want to put the 3 down here and the 5 up here, because then I've got a GCF of 3 on this row. And that makes me sad, right? So what I'm going to do is I'm going to undo that. All right? And what I'm going to do is I'm going to put the 3 up here where it's not a GCF, and I'm going to put the 5 down here. Okay? All right, and so now I'm going to get ready for the second step. Now, I do want to highlight a couple of things. Don't forget that you can flip. In this particular circumstance, I can't, or maybe I did, right? I accidentally put the 3 on the bottom. I accidentally put the 3 on the bottom and the 5 on the top, and then I realized that was a GCF, and that made me sad. So what I did was I actually flipped them, right? Because I can never put a GCF on the same line. And then, of course, I always want to make sure that I work my way up the list using the closest together first. So if for some reason the 2 and 3 and 3 and 5 didn't work, what I would do is I would head up the list and I would say, which is closest together, 1 and 6 or 1 and 15? And of course 1 and 6 is closest together, so this would be my next choice to plug in. Alright, and so now we're ready for step 3. Okay, so again I'm going to scroll up. Hopefully I've gotten the hang of this now. Alright, great. Okay, so now for step 3, what we want to do is we want to follow the x and multiply the terms together. And this will make a like term, like terms, with the middle term of the trinomial. Okay, so what I'm going to do is let me go ahead and draw this in so that we have a good idea of what's going on, right? So remember, we did 1x, and we did 6x, and I did 2x, and I did 3x, and I did 1 and 15, and 3 and 5, and I drew my x, and I put the 2x in front, and the 3x in the back, and then remember I had the 3 up here, and the 5 down here. And now what I'm going to do is I'm going to multiply the terms together by following the x. So literally, I'm going to take 2x and come down and multiply it by 5, and that's going to give me 10x. Okay, and then I'm going to take 3x and go up here to 3, and so 3x times 3 is 9x. And now you can see the 9x and the 10x are like terms with this middle guy right here, the negative x. Okay, so the question is, can I combine the like terms in such a way that I get that middle term? Is there some way to put 9x and 10x together such that I get negative x? And hopefully what you see is if you subtract 10x from a positive 9x, that will work, and that makes us happy. Okay, so what I'm going to do is I'm going to put a negative in front of the 10 and a positive in front of the 9, because that's the way that works. And now we're ready for the next step. Again, hold on, wait for it. Again, if it doesn't work, flip, move to the next closest together, etc. All those things in the previous step. Okay, so that's what you want to do. So what am I going to do with this now? What does this tell me? All right. So now, of course, I'm going to scroll up again. Okay, and so the sign is going to stay on the same row, and now you have your factored form. And so as I go up here, hold on, right? I'm going to draw in. The same row is here, right? This is the same row as this negative. And so what I'm going to do is that negative sign goes right there. And of course, this is the same row as the 9. And so I'm going to go ahead and put the positive there. And now you actually have your factored form. What are the two factors? The two factors are 2x plus 3 from this row right here, and from this row right here, 3x minus 5. All right, and this makes us super happy. But wait. All right, there is one last thing that we have to do. I know that the 2x and the 3x give me 6x squared, right? I know that 3 and 5 give me 15. And I know that the plus 9x and the negative 10x give me this negative x. The only thing I haven't determined is the sign of this guy right here. And so for step number 5, I need to check the signs. Alright, and so of course then step 5 is to check the signs using the distributive property. And if it works, you're going to be done. Now, unfortunately, if not, you do need to go back to step number 3. But again, I'm going to scroll this up just a hair so that we can see this. And so I'm going to go ahead and do the distributive property so you can see what happens, right? And so 2x times 3x, I'm going to have 2x times 3x, okay? This was the factor pair I started off with. And then I'm going to have 2x times negative 5, right? And so I'm going to have a negative 2x times 5, right? There's that negative 10x, right? There's that multiplication along the x, right? Oops, there's, I went too far. There's the 2x, there's the negative 5, and there's the negative 10. All right, and so now I'm going to go ahead and multiply positive 3 times 3x, and so I'm going to have positive 3 times 3x, and again you can see the 3x times 3 giving us the 9x is right there. And this is why the x factor method works, right? This is why this works, is because the x does the distributive property for us to get those middle two terms. And then this is the one that I'm really concerned about, and this is the 3x and the negative 5, and so I'm going to have a negative 3 times 5. Now, I will note this is the long way to do this, but I'm doing it to illustrate why this method works and where all these numbers come from. And so now, of course, 2x times 3x is going to give you 6x squared. This is going to give you a negative 10x, right? This term right here. This term right here gives you your positive 9x, right, which we know are like terms. And a negative 3 times 5 is a negative 15. And this is what I want to see. The signs work, which makes me super happy. And so now I'm just going to combine my like terms, and I'm going to get 6x squared minus x minus 15, which is what I'm supposed to have. And so there's my check, and that makes us happy. I hope you enjoyed this video. I hope you find the X factor method much better than the AC method. And so enjoy. That makes me happy.